Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on antenna. Okay, so for this video, okay, I'm going to discuss one of the key parameters of antenna, okay, which is antenna gain. Okay, so antenna gain is actually quite different from the word gain. Okay, so basically, I guess that we are actually very familiar. Okay, what is the definition of gain? Okay, so basically for gain is basically to boost a very small signal into a very large signal. So basically, in short, for gain is basically convert a small electrical signal into a large electrical signal. Okay, but for antenna, is actually totally different. Okay, for the role of the antenna is simply to convert electrical signal into electromagnetic wave. So therefore, the way how we describe for antenna gain is completely different from what we describe on the word gain. Okay, so over here you can see that typically we will use two forms to describe the antenna gain. Okay, either dBi or dBd. Okay, so this video, I'm going to explain the key difference between dBi and dBd. Okay, so dBi is basically compare the antenna versus a isotropic antenna. Okay, so therefore the I actually stands for isotropic. Okay, as for dBd, okay, the word D is actually compared against dipole antenna. Okay, maybe in short, I give you an idea. Okay, so for me, okay, most of the time when we actually describe an antenna in a theory manner, then we will use a dBi. But when we actually describe an antenna in a test and measurement environment, then we will use this dBd. Okay, so this video, okay, I'm going to emphasize, okay, again, like what I mentioned, I'm going to emphasize the key difference between these two. Okay, so this will be the part 4 series discussion on antenna. So guys, if you're keen to know more about antenna, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on antenna. Okay, so this is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if you guys want to have a faster response, okay, ask me your question through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. Okay, for those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. Okay, I have showed this on the part 3 series discussion on antenna. Okay, so these are all the parameters of antenna that I will describe but on the next few video also. Again, like what I mentioned earlier on this video, I'm going to concentrate on the gain. Okay, on the part 3 series discussion, I have mentioned about radiation pattern. Okay, in fact, there are 3 types of radiation pattern. Okay, so if you want to have a deeper understand on radiation pattern, okay, you can always welcome to see the part 3 series discussion. Okay, so this video, okay, I'm mainly concentrate on antenna gain. Okay, so what is actually an antenna gain? Okay, before I go into discussion on antenna, actually someone asked me, okay, what is actually an antenna? So basically this few slide, I'm going to explain what is actually antenna. Okay, so over here you can see that there are actually a transmitting antenna and receiving antenna. Okay, so what are they? Okay, so a transmitting antenna can be viewed as a device that convert a guided electromagnetic wave from a transmission line into a plane wave propagate in free space. Okay, let me describe this here. So you can see that this is actually a transmitting antenna. So basically you can see that this device here, okay, they basically have this guided electromagnetic wave. You can see that, for example, okay, when we want to send a signal to a particular direction, okay, so what happened here is basically we point the antenna, for example, to a certain direction, and you can see that basically the initial release of the electromagnetic wave, they are so-called the guided. You can see over here, they are actually guided to a specific direction. So therefore, this is what we call a guided electromagnetic wave. Okay, so basically, this is what it means here. Okay, thus one side of the antenna function as electrical circuit element. Okay, so you can see that this will be like electrical signal convert to electromagnetic wave. Okay, but let me just describe this. Okay, you can imagine that this thing actually getting bigger and bigger. Can you imagine this? So once they become bigger and bigger, they actually become a plane wave. Okay, I'm not sure whether can you visualize this. Basically, you can imagine that this is basically become bigger and bigger, and by the time it reaches so-called an antenna, probably kilometer away. Okay, this thing actually behave like a plane wave. So basically, this is what we call a guided. This is basically what we mention as a plane wave. Okay, so the other side, okay, which is the receiving antenna here, basically you can see that they basically interface with a propagating. Okay, so this thing is actually a propagating plane wave. Okay, so basically they receive this signal here. Okay, antenna are basically bi-direction, okay, which means that they can behave like both the transmitting and receiving antenna. Okay, the transmitter can be modeled as a turbine source. Okay, so basically this will be the turbine source here. Basically, they consist of a voltage generator. You can see that this is a voltage generator, a series impedance. Okay, so basically this will be a series impedance. What they do is basically they deliver a power, okay, transmitting power to the transmitting antenna. So over here, you can see that these are all still electrical signal. So once they reach the antenna, basically the role of antenna will convert them from electrical signal into electromagnetic wave. So basically this will be what we call a guided. This will be under the plane wave. Okay, so the transmitting antenna actually radiate a spear wave, okay, that at large distance can approximate a plane wave. Okay, so basically this is what I mentioned earlier on. You just imagine that this so-called guided spear wave, okay, at a long distance, okay, they actually become a plane wave. Imagine that you draw this on and on for a few kilometers. Okay, I definitely cannot draw this at a few kilometers, okay, because I don't have so much space. But you just imagine this electromagnetic wave actually travel a few kilometers, for example. Okay, so you can imagine that they actually more or less emerge into a plane wave. So this is what it means over here. Okay, the transmitting antenna actually radiate a spear wave. Okay, after a long distance, okay, they actually approximate just like a plane wave over a localized area. Okay, a receiving antenna actually intercept a portion of the incident plane wave. Okay, so basically they intercept this signal, and what they do is basically they deliver this signal, okay, as a receiver power, okay, to the load. Okay, so basically this hopefully give you a better idea what is actually a transmitting and receiving antenna. Okay, so another useful measure to describe the performance of antenna is to use the antenna gain, as I mentioned earlier on. Okay, in a transmitting antenna, okay, the gain describe how effective the antenna actually convert the input into radio wave or EM wave direct towards a specific direction. Okay, for antenna, most of the time, let's say we have a intent direction to send over. Okay, so basically this is the definition, okay, for this transmitting antenna. Okay, in a receiving antenna, okay, the gain actually describe how effective the antenna actually convert the EM wave, okay, arriving from a specific direction into electrical power. So over here, you can see that the behavior of transmitting antenna and receiving antenna, they are totally different. For transmitting electrical signal to electromagnetic wave signal, for receiving electromagnetic wave into electrical signal. Okay, so over here you can see that when we actually don't have any direction that we actually want to specify, okay, the gain is understood to refer to the peak value, okay, which is the gain in the direction of the antenna main loop. Okay, so this no worry, okay, later on, okay, I guess, or maybe later on through the discussion, okay, you will be able to understand this better. Okay, so let's do some key point to describe the antenna gain. Okay, so come to the definition to describe antenna gain. Okay, again, firstly, we can describe the antenna gain by using a ratio or numerical ratio. Okay, the gain can be expressed as a number, okay, which is the ratio of the power radiate in a desired direction to the power that radiate by an isotropic antenna. Okay, so basically, let's not dwell so much. So in short, for example, okay, you have some gain number. What is actually gain? So gain is actually a number that actually you measure the power that is released by the antenna, okay, over the isotropic antenna. Okay, so basically this is what we call a gain, okay, or maybe dBi. So later on you will understand this later on. Okay, so no worry about this. But over here, just want to quickly understand that you can actually describe antenna gain, okay, by this way. As he mentioned here, the gain can be simply expressed, okay, as a number, okay, which is the ratio of the power radiate. Okay, so basically these are all in ratio. Okay, in what? Okay, so basically in the desired direction. Okay, over the power that is radiated by an isotropic antenna. Okay, no worry. So basically, this is the power that we actually radiate out and versus the power that is basically so-called radiated out by the isotropic antenna. Okay, so basically, these are mainly all described in decibel. Okay, most of the time we will describe that in decibel. Okay, so as I mentioned earlier on, there are actually two ways. Okay, so basically there are actually two reference antenna. Okay, one is what we call the isotropic antenna. Another one is what we call the dipole antenna. Okay, so what is actually a isotropic antenna? Okay, basically this is ideal point. Okay, they basically radiate equally in all directions. Okay, which means that the power that they actually release, they are all equally in all directions. And the gain relative to this is actually denoted as dBi. Okay, so basically, I will mention what is dBi here, but let's quickly understand what is a dipole antenna, dBd. Okay, so dBd, as I mentioned earlier on, is basically used as a reference, okay, against the dipole antenna. So the D is actually from the word dipole here. Okay, so over here you can see that it's a very simple, okay, half-wave dipole antenna. Okay, the gain relative to a dipole antenna is denoted as dBd. Okay, so this one you don't need to note first, but over here I just want to make the discussion complete. Okay, note that 0 dBd is actually approximate 2.15 dBi. Okay, so I'm not sure whether you still remember on the first slide, I mentioned that this isotropic typically will be used to describe the antenna in a theory manner. Okay, as for dipole, okay, we will describe this form in a test and measurement environment. Let me further explain this why. Okay, so basically, for example, when you actually build an antenna, okay, so how to describe the antenna gain? So basically, in short, you can actually describe the antenna gain versus an isotropic antenna, okay, which means that they actually radiate equal power to all directions. So basically, from here, you will be able to determine the performance of the antenna that you actually build. Okay, however, when we actually want to do a test and measurement, okay, so if you know that this isotropic antenna is almost not possible to build, who can build an antenna that radiate, okay, very evenly, okay, in all direction and also regards on the power? So hence for isotropic antenna is in the ideal world, okay, no one actually can have this isotropic antenna. So therefore, when we actually want to do a test and measurement, okay, we can't reference against isotropic antenna because we can't find this isotropic antenna. So over here, you can see that when we actually want to do a test and measurement, we will use a dipole antenna. Okay, the dipole antenna will serve as a reference antenna to determine the gain of the antenna that we actually want to undergo the test. So basically, this is the key difference. Isotropic will be used, okay, when we actually mention antenna in a theory manner. Okay, this is because when we actually use this dipole antenna, okay, dipole antenna, again, you can imagine that everybody will have a different dipole antenna, and all the dipole antenna will have different performance. So hence, it's almost impossible to describe your antenna gain, okay, by using this dipole antenna as a reference. So in short, when we actually want to describe them in a theory, then we will use this dBi. We will compare our MIG, so our test and measurement antenna versus an isotropic antenna. So you can tell everybody what will be the dBi. Okay, so basically this is under what we call the theory way. Okay, but when we actually do the test and measurement, as I mentioned earlier on, there's no way that we can have an isotropic antenna. So hence, in order to have some form of reference, then we will use a dipole antenna as a reference. So basically, in short, this is the key difference between dBi and dBd. Okay, so let's quickly understand on the gain here. Okay, the gain of an antenna, okay, basically it will have certain direction that you actually want to send a signal over. Okay, it's defined as the ratio of the intensity in that direction to the radial intensity that will be obtained if the power accepted by the antenna will radiate isotropically. Okay, usually this ratio is expressed in decibel with respect to an isotropic radiator. Okay, so what does this mean? Okay, so basically imagine, okay, will be the location of an antenna. Okay, so imagine there are actually two types of antenna. Okay, so let's say the first one that I'm going to put this antenna will be an isotropic antenna. Okay, so you can see that they basically will radiate, okay, evenly. Okay, all of them will have equal power evenly. So therefore, this is what we call an isotropic antenna. All the power that they will receive will be evenly. Okay, let's take a look on this green one. For example, this is a very directive antenna. I actually want to send to a particular direction. Okay, so therefore you can see that the pin actually so-called tilted towards certain direction. So basically this is the directive antenna. So what is actually dBi? Okay, so basically dBi, this will be your reference. Okay, your reference measurement is from here to here. And if you want to mention about dBi, okay, will be from here to here. Okay, which means that this is the amount that is larger than isotropic antenna. So basically with this, you can actually roughly describe the performance, okay, of the antenna that you actually build. Okay, so basically, just to be very fair, okay, basically to have compare the antenna that you build against the isotropic antenna here. Okay, so another alternative definition compare the receiving power to the power that is received by a lossless half-wave dipole antenna, okay, in which the unit are written as dBd. Okay, so basically you can see that basically if you still remember on the part 3 series discussion, I have mentioned that dipole antenna, what is actually a dipole antenna? They basically most of the time will be radiate, okay, in an ohmic direction. Okay, so basically they will radiate in a horizontal manner. Okay, so if you are not sure about this, okay, always take a look on the part 3 series discussion here. So basically when we actually, for example, okay, as I mentioned, there's no way that we can have this isotropic antenna. When we actually want to quantify, okay, an antenna that we actually build, we want to have this test and measurement result. Okay, so because we can't build this isotropic antenna, so hence the reference antenna, okay, we will use this dipole antenna. Okay, so next slide you will understand better. Okay, so gain is a uniqueness measure. Okay, they basically combine an antenna radiation, okay, and also efficient. Okay, so basically in short here, gain is actually proportional to the efficient and also the directive. How directive that you actually want the antenna. Okay, although the gain of the antenna is closely related to the directivity, okay, it is a measure that take into account the efficient of the antenna as well as the directive ability. Okay, so basically in short here, antenna gain is actually depend on mainly, okay, firstly on the efficient, how efficient you actually can send out a signal and versus the directive. Okay, so basically this is the quick definition about antenna gain. Okay, so basically you can take a look on this diagram here. Okay, so you can see that conventionally when we talk about gain, it's basically electrical signal to electrical signal. Okay, but over here, okay, basically you can see that the gain, okay, they also depend firstly on the efficient, and they also depend how directive you can actually send the waveform over. Okay, so basically this gives you a better idea on antenna gain. Okay, so most of the published antenna gain, okay, the value are often expressed in dB or decibel. Okay, so basically, for example, when we actually want to describe this, okay, which is GdBi. Okay, so basically this will be the gain, okay, over 1. Okay, why over 1? You can see that this is actually an isotropic antenna. You can see that the gain is actually 0 dBi. Okay, which is a reference over here. This will be 0 dBi, and whatever that is more than that will be the gain of the measured antenna. If you still remember, I told you that we are going to put 2 antenna over here for measurement. Okay, one will be your antenna that you actually built. Okay, so this one we call a test antenna. Okay, another one we call a reference antenna. Okay, the reference antenna will be isotropic antenna. And over here, you can see that this will be so-called 0 dBi. Okay, so basically 0 dBi, the ratio is equal to 1. So therefore, the meaning of 1 is basically I compare the gain, okay, the gain of the antenna over the gain. So basically, I compare the gain over here, okay, over the gain of the isotropic antenna. Okay, so this will be described in so-called gain in dBi. Okay, so basically this will be in a ratio manner. Okay, so therefore, give you an example. Okay, when an antenna with a peak power gain of 5, okay, would said to have a gain of 7 dBi. So this is 5. Log 5 will be multiplied by 10 will be equals to 7 dBi. Okay, so therefore the term dBi is used instead of dB, okay, to emphasize that this gain is defined in comparison to an isotropic radiator. Okay, so I guess now you will have a better idea what is actually a dBi. Okay, when an antenna maximum gain is specified in decibel, okay, so basically when you actually make, for example, some manufacturer, they make an antenna, okay, so basically they describe them in decibel, which means dB only. Okay, so hence it is essential, okay, to determine whether this gain is relative to an isotropic radiator or the typo, okay, which is dBi or dBd. Okay, if it's specified in dBi or dBd, then there won't be any ambiguity. Okay, so however, if only dB is specified, okay, the fine print must be consulted, okay, which means that the fine print must include whether is it response to either isotropic or a dipole antenna. Okay, however, okay, an isotropic radiator cannot be constructed. Okay, as I mentioned earlier on, isotropic radiator or antenna is actually very challenging to me. Who can build an antenna that can radiate evenly at all directions? Hence, this is under the ideal antenna and is almost not possible to be described. So in practice, a half-wave dipole antenna, okay, which is easily reproduced and can be constructed for any frequency is used. Okay, the key reason why we want to use a dipole antenna is because, because the dipole antenna, we can reproduce them easily. And we can also have various frequencies. So hence, we actually prefer to choose the reference antenna. We would like to choose the dipole antenna. Okay, the directive of the half-wave dipole antenna relative to an isotropic radiator is known to be 1.64. Okay, so basically the difference is 1.64. And it can be made nearly 100% efficient. Okay, since the gain is measured relative to this reference antenna, okay, the difference in the gain of the test antenna is often compared to that of a dipole. Okay, so as I mentioned earlier on, okay, because you are going to do a test and measurement, okay, for example, for this case here, I have a test antenna. Okay, so I put the test antenna inside and done the measurement. And next, I also have the reference antenna, which is the dipole antenna. And again, later on, I will emphasize how we actually can get the dBd value. But over here, you can see that when we actually use this, we actually use this dBd to describe the performance, okay, rather than dBi. Okay, so basically over here, I guess now it's pretty clear. Okay, dBd mainly will be used under the test and measurement. As for dBi, typically we will use this under the theory portion to determine the antenna gain. Okay, so thus in terms of true gain, okay, the gain for this antenna will be in this form here. Okay, I put the gain that we actually defined earlier on. Okay, because okay, if you still remember, okay, because of this isotropic antenna, this gain is 0 dB. Okay, so basically 0 in ratio will be equals to 1. So you can see here on the ratio is equals to 1. Okay, so basically this will be versus the dBi antenna. And we actually do this dBd, as I mentioned here. Okay, so basically when we actually compare the dipole antenna to an isotropic antenna, okay, we know that the ratio will be 1.64. Okay, so over here you can see that this is actually referenced against the dipole antenna, so hence it will be 1.64. So basically this will be the value, okay, for the gain under dBd. Okay, for instance, the above antenna with a gain of 5. Okay, so a gain of 5, if you still remember earlier on, we calculate, okay, the G in terms of dBi will be equal to 7. Okay, so basically we'll have a gain. Okay, so basically this is slightly different. We need to calculate the dBd. Okay, so with respect to a dipole, okay, so basically we again will be the same gain, which is 5. Okay, so for dipole will be 1.64, and from here you can calculate that this will be at 3.05. Okay, so basically this will be the ratio. Okay, or in decibel, okay, basically what we need to do is 10 log this number. Okay, so this thing will be equals to 4.85 dBd. Okay, so in general, okay, so you can see that basically the key difference between dBd and dBi can be expressed in this equation here. Okay, so with this, I'd like to end my discussion. Okay, I guess from here, you will have a better understand how to describe antenna gain, okay, using GdBi and also GdBd. Okay, so for the GdBi mainly are used for theory, and basically the test antenna is actually referenced against isotropic antenna. Okay, for GdBd, okay, basically will be the test antenna with reference to a dipole antenna. Okay, as I mentioned earlier on, okay, for theory we will use GdBi, okay, because we can't so-called have a reference antenna for everybody. Okay, everybody will have a different reference antenna, so the result actually vary. Okay, so therefore, in order to fully complete describe the antenna in a theory manner, then we will use GdBi, okay, to describe the antenna gain of the antenna that you actually manufacture. However, okay, when we actually do the test and measurement, then we will do this DBD to describe the antenna again. Okay, with this, I'd like to end my discussion. Please help to like and subscribe. Once again, thank you so much for your strong support. I hope to see you guys soon. Bye for now. Thank you.